All right. Welcome everybody to Dash Platform Development Update. My name is Balazs Bezi. I'm supporting the development protocol, the platform development teams. And we slightly renamed the sprint reviews from last time as we thought it represents what we are doing here a little bit more. We've seen each other like 10 days ago, so we had a little bit less time to prepare and impress you, but we are happy to show you what we've done in this past 10, 11 days. We are planning this session for 60 minutes as usual, and just as usual, feel free to leave your comments in the live chat below. We will have a dedicated Q&A session at the very end, and we will try to answer all of your questions. As this is the platform development update, we cannot answer all of your questions regarding to Dash, but we will try to address all those that relates to this update. All right, without further ado, I would like to pass to the first team, which is TenderDash, starting with Lucas.
Hi, so basically we are working on same block execution, which is a change on how we execute transactions and how fast the output of a transaction can be applied. Dima in previous calls did give you some more background about that. Let me just quickly update you that we are still working on this. Basically, the API is more or less ready. We are waiting for feedback from the Drive team if anything needs changes. And we are right now stabilizing the tests. And we have two types of tests. First one is unit tests, which pass right now. And today we merge, I think, final fix for this, with one exception, which I will mention in a moment. And right now we are working on stability of end-to-end tests, where we have a network of validators that communicate with each other. So that's where we are right now. And during the work, we found some deadlocks in the consensus engine that we have inside TenderDash. And this is something that we need to investigate in more details and maybe do some refactoring in order to avoid these deadlocks, because they can result in network halt that will require restart of TenderDash, which is not acceptable. So we need to work on that, and of course continue working on the same block execution. And that's our plan for the next few weeks.
Thank you very much. Let's just continue with GroveDB, and I pass it to Wisdom.
Hey guys, my name is Wisdom from the GroveDB team. The goal of this sprint was fee continuation and some trees. So next slide. Okay, so some trees is almost done. We have implemented the Merc aspect of this. So Merc has the trees, and then they are able to sum their values. And then the GroveDB interface has been created to make use of this feature from the lower level. And now we are working on the sum tree propagation. So basically, this allows for sum trees within sum trees. And then you've been able to retrieve your tree element and get the sum that it represents in the underlying Merc. So this is still in progress. We're going to have a demo for this in the next review. to show this functionality. And I'm going to pass it over to Sam to talk about the root tree storage.
Yes, hello. I'm Sam, CTO at Dash Core Group. Very quickly before I start on my topic, I did want to say for people who might be wondering, we had originally planned on making a high-performance masternode presentation at the end of this review. We instead are doing it on Friday as the main researcher who was going to present is out sick. So stay tuned at Friday at 3 p.m. Okay, on to root tree storage. So this comes at the back heel of the work that was being done on fees and costs. And while there was work on costs, it was minimal. So I didn't really add it to to stuff that was done. Instead, I really wanted to concentrate on the biggest task here, which was the removal of the root tree storage. And this kind of came as a task that we had not really planned. It was because of an incompatibility with our cost model and the way we were holding Merck root trees. And to explain that, I've made a few slides. So can we go to the next slide? Yeah, so the biggest problem is that we have a root tree storage that is incompatible with our fee model. We have to kind of understand how our fee model works first. In our fee model, every node in the system has an owner, every storage node. Like that, if you remove the storage node, people get the fees of that item back. Now, a node, let's not confuse like master node type node. This is a database node in a Merkleized tree. So here is kind of like an example. In blue, we have different nodes on 2 levels. Above is the parent tree, which would be the 1 level above. Our GroveDB is actually kind of a 3-dimensional Merkleized tree where you have different levels of nodes. But that's not that important. What we had done to save time in the past was we kept Merck's way of storing the root key on each level. And this was basically to save time. The problem, though, is that each Merck tree at each level can rotate left, right, all around, and the root key constantly needs to change. Now, that might not seem like a big deal, but the problem is as the root of the nodes change, let's say, for example, let's give an example because this will be more easy. I create a node where I insert a document because I want to put in that I own a blue car, right? Now, Wisdom comes in and inserts another node. He owns a red car. And now Ivan comes in and he puts in another node and it says that it's a yellow car. Now, at the very beginning, when I inserted my value, I would be at the top of the tree because I would have put in a blue car, and blue starts with a B. Well, I mean, no matter what, it's one element, so it would be at the very top of the tree. Now, when Wisdom inserts his element, since there are only 2 elements to the tree, his element would be to the right of the tree. R is red. Red is the R is after a B in the alphabet, so it basically would go on the right side. Now, if we think about Ivan when he puts in the yellow car, it would be right and then right again, which would cause a rotation of the tree. So you would have your top element, middle element, the last element at the bottom right, and it would cause a rotation like this. So the top node that had the root basically would no longer have the root. This would actually, in the old system, before we have made these changes, this would actually mean that money would need to be given back to the person that originally had the root of that tree. and then more money would need to be paid by the second person, here wisdom, when Ivan inserted his element. And obviously that is preposterous. We don't want one user inserting documents and having another user pay additional storage. So what we had to do is we had to figure out kind of how to solve this issue. And it wasn't that hard to figure out how to solve, because we were using this root key storage. And actually, let's go to the next slide, please. Oh, this is actually an example of what I said before. The previous top node goes to the left, then the right node goes up, and then there's a new right node at the right. Okay, let's go to the next slide. So the solution is basically to use the parent trees to store the root key of the underlying mercs. So this actually had been thought of before, but we had decided to put it after our first release because of its complexity and changes in the system. But of course, if it's incompatible with the fee system that we have, well, we have to solve it. So here we are solving it. Now, not only does it solve this issue with fees, it also provides a good cost benefit. When we look at what it means when we remove the root key storage, actually, let's go to the next slide. Yeah, we actually have quite a lot of cost savings because we remove this root storage cost, where we remove basically the key and the path hash. So we have whatever bytes the key costs. We remove the path hash, which is 32 bytes. And we also remove the, okay, so let's go back one slide, sorry. Yeah. So the parent tree before, the value happened to be the subtree root hash. And well, that is not really necessary, because if you think about it, there are two items inside a node, which is the value and also the value hash. Now, the value hash, just as in a reference, could be something else. So when we can make the value become the subtree root key, and the value hash become the root hash of the underlying tree. I'm really sorry for all those watching. I know this is very complicated. I did want to give a presentation on it for potentially people inside DCG and potentially in Incubator, or anybody else who is very interested in trees and really, really loves trees. But yeah, so what people that are not that technical need to understand is basically we're saving about 64 bytes on each layer connection, which is actually really great. So it will really lower the cost of storage. Yeah. Okay, that's it from me. Let us go to what's next. So this has been, I would say about 50% of the development of this has been done. It was a pretty strenuous feature. A lot of code has to be changed. Once all that code has changed, then we have to re-verify all the costs because it's a big change. And then after that, we have to also deal with worst case costs changing because we no longer have a root tree. This is probably going to take a whole sprint, in my opinion, but it might be less. I would prefer, since there are always some things that pop up, I'm now preferring to say a little bit less than too much. And with that, let us go to SDK.
Hey everyone. So the goal for the sprint remains. We are reworking chain synchronization process. And on the last QA session, Adam, our QA, have found some bugs, which made me realize that it doesn't really make sense to introduce any more patches in order to fix them, but rather the whole transaction synchronization module has to be refactored and properly covered with tests. So this is basically what I was busy with last week. And unit tests are on 75% of completion, and integration tests at 20%. So the goals for next sprint is slightly changed. Originally, we planned to work on reworks and consensus rules, but right now we decided that we have to finish this refactoring, QA it once again, and continue with testing with platform and testnet. This is it from my side. Thank you.
Thank you, Igor. All right, let's move on to protocol. And
hello, everyone. My name is Ivan Shmukov. So let's talk about what we have done this sprint on protocol team. Our main goal was to release the platform 23 alpha version, and let me explain what is that and why we decided to go with it. So as you already mentioned, notice that we still continue to work on this system in our underlying layers and storage, mostly in GroveDB. And we continue to develop 24 version, which is somewhere in the middle, and we decided it's probably we don't want to keep the existing functionality in version 23 in the table and start testing earlier. Also, current version on testnet, what we have, had a pretty bad source of non-determinism, which led to chain halts potentially, and we had them from what I remember at least 5 times during this year, and so it's not really stable. You probably remember all these wipes because it's only the way how to solve such chain halt at this point. Also, platform 23 supports new core 18.1 and new architecture. What we are looking for, what we're going to test and eventually switch on the testnet. I mean, switch to our nodes because they're at least cheaper. That's our plan for next year, but we would love to start this testing before, so we'll be ready for the upgrade next year. So we already released alpha.1. You will see soon alpha.2 with some additional fixes. And today we started to upgrade our testnet. This time it's not so smooth deployment as usual, because new 23 version of network and platform, they are based on the new Ubuntu image, the new OS. So we need to rebuild the infrastructure completely and migrate the layer 1 data to do not lose the blockchain. And this we're planning to do this work during 2-3 days until we can replace old nodes, the new nodes, and after that we will be able to upgrade platform. So together our Dashmate and SDK as well as the platform components are released. of the alpha version, and you can use them to interact with testnet. Please specify the exact version to install the Dashmate, also to use the SDK. And I hope it will be like on the 6th of October, testnet will be ready so you can continue to test and work on your stuff there. Yeah, thank you. Javid, would you like to continue?
Yeah, hello there. So quick update about the withdrawal queues. So today we're kind of finalized it, but it's still lacking review and some polishing probably. So that's the quick update about it. Ivan?
Kostya, are you with us? Would you like to cover the task what you're working on right now?
Yep, sure. So my name is Kostya, and as I mentioned our previous sessions, we started implementing SSL support in platform in DAPI, DAPI clients and Dashmate as well, and you you can use either your own certificates or you can use self-signed certificates for local development, or you can use zero SSL certificates if you don't want to issue certificates by yourself. This is the only provider that we support right now, but we can easily add another providers if we need it in future. Yeah, and right now it's almost done. I mean, the last part is certificate renewal tool, which will renew certificates from zero SSL provider. And if you use it, the process for you will be super smooth because it will be renewed every time. Sorry. It will be renewed automatically, so you don't need to think about it at all.
Yeah, thank you. So basically, it's like, as Kostya said, it's completely automatic process. And when you set up your testnet node with Dashmate, you just say like, hey, I want to go with the zero SSL. You specify your API key. And after that, Dashmate take over this routine and you'll be fine. This last task related to HTTPS for DAPI. So when we finish, Dashmate will be ready, and this will go to the version 24 of the platform. And we are going to prepare our network deployment tool to, let me put it another way. So right now, deployment tool is using some legacy way to set up nodes, like master nodes, platform nodes on testnet, on other like devnets, other networks, and which is a little bit obsolete, and we need to support both versions, like basically both implementation, Dashmate to run the node, and also this one from the deployment tool. So to support, like to remove this legacy and support HTTPS on testnet, so we decided to integrate Dashmate into deployment tool. So since version 24, I hope we will start our nodes with Dashmate, and we will enable HTTPS for testnet for version 24. So that's our plans. Also, we worked on the multi-transaction support in Drive. Transaction here means the database transaction for GroveDB, not the blockchain transactions. And this functionality we need for the upcoming same block execution integration. The work with was done with the TenderDash team working right now. We having this multi-transaction support will be able to integrate this logic. I probably explained the details last live review, and just briefly. So the problem that for the same height you could have multiple proposals, and for each proposal you need to execute state transitions and calculate app hash, but you don't know at this point which proposal eventually will be committed as the block, and which will win during the validators voting. So you need to keep all these versions of the state basically simultaneously, and when validators vote on the one of the proposal will reach the majority of votes, will be eventually committed to the disk. So there is some technical difficulties with that, and our great Rust brain came back to us today, so I hope we will solve it soon. Yeah, and during the 23 version deployment, I mean alpha version, we find several bugs and fix them, and one of them was this pretty bad one, which we struggled with during this year. So I'm very happy that now is our system much more stable, and we can continue testing 23 on testnet. Yeah, so our upcoming plans are still to accomplish and continue the system. We will continue to work on withdrawals. We have like at least 2 more epics. So right now we're doing the queuing, signing of this transactions, withdrawal transactions with quorum, and then broadcasting to core. And next thing will be to implement retry logic for withdrawals in case if withdrawal transactions won't be mined for some reason by core miners. So there are stuff to do still on this area. We will continue to work BLS right binding, which we paused for last sprint because some of the people were took vacations and they have some difficulties because of traveling. Also, we're gonna finish the HTTPS for DAPI and jump on same block execution integration. I guess release platform V23 here by mistake. It's released, but we will continue deployment next sprint, and I hope this week we will see 23 alpha working on testnet. Thank you.
All right,
so
thank
let's
you.
continue with DPP.
Can I pass it to Anton?
Sure. Hey guys, Anton's here. And I'm going to give you a quick update on the Rust DPP port effort. As we've seen each other like the last week, there's not that much update as we usually have, so it will be rather short, I think. We've completed 2 more tasks from the V23 initiative port, and that brings us to total 18 out of 21, which means that we still have 3 more tasks to finish to complete the V23 porting efforts. And on the Rust DPP binding side, we're trying to finalize the API, to stabilize API before moving with implementing bindings for all the other structures. And we are working on cross-language interoperations and how to make it work as seamless as possible, because when your protocol library is in one language and your main chunk of software is going to still be in another language, being JavaScript, for some time, we need to think how to integrate them together in a way that makes sense. Unfortunately, we have to make sacrifice somewhere. So it's there should be when we're working with bindings, there are always some workaround involved in this. We were deciding on what workaround we're going to use and where it's going to be and how to minimize the problems that we can possibly have as a result. I can give you an example of that. For example, for the people who are on a more technical level and actually want to hear about more details. For example, when you go through the cross-language barrier, JavaScript has a buffer class, not JavaScript, but Node.js, and we've used polyfill for the web side of things, for the JavaScript side of things. And it just does not exist really in the Wasm bindgen, which we use to port Rust DPP. And we were thinking about what would be the better approach in this case. For example, we can just use arrays, we can just use uint8 arrays, we can do something like extern C on a Rust site to actually import the buffer class and then manually do conversions when we need them, things like that. And right now we tried a couple of different approaches to the problem, and I think we kind of in agreement now how it should look like. And right now we are proceeding on stabilizing the API between the Wasm DPP binding and the rest of the platform. Well, that's about it. Thank you very much, guys.
Yeah, Anton, I need to correct something you said though, really quickly. You said the majority of our platform is in JavaScript. That's not actually true at the moment.
Well, yeah, it's hard to estimate right now, I think, since, well, yeah, we have TenderDash now and Res Drive and stuff like that, yeah. But kind of, still a big part of platform is still written in JavaScript.
Yeah, about maybe, yeah, but only 1/5 of the teams presenting here, right? And even not everything. Okay.
All right. Thank you very much, Anton, for the update as well. And let's see what questions do we have. I only see one question regarding deadlines, which is, I'm not sure which deadlines.
Yeah, they're basically the question. I'll answer that one. You can hear me, right?
Yes.
Yes. Okay. The question is basically around deadlines and do we have them? Yes, we do have internal deadlines. We basically figure out how long a specific task is supposed to take, and we try to put it in, and estimate it and figure out how long it's going to take. The problem then comes as if the deadline is not met. it's not as if you can always know in advance everything that can go wrong. So sometimes, for example, in the case of what I was dealing with fees, we definitely all believed that the root tree system was going to be good enough. And then later down the line, we, came to the conclusion that it just couldn't work. So some extra, so like an extra feature had to be written. These push back things like V23. And it is true that in an ideal world, what we can do is, spend time at the very beginning, fleshing everything out. The problem has been that when we have tried that in the past, where we have written everything down, and it generally led to much longer development times when that was tried in previous years. So it does seem like at the moment in what we see from how much code is being written, we are writing pretty much the most code that we've ever written. And it is going pretty fast, but sometimes deadlines, they either slip because there's something that you didn't think about, or they slip because of somebody not, people being sick, people fleeing their home countries. Many things can go wrong, especially in this day and age. So.
And I would like to highlight that we are operating in a research-heavy environment. So no one did what we are doing right now. And basically, it is really hard to give deadline any research-heavy topics. Like you don't ask researchers that when will they discover the antidotes for cancer or these type of things, because there's a very a lot of unknown in the equation.
Well, so to answer what Dave just said, he said at the rate things are going, we'll have delays until 2050. No, we won't. We'll either be dead or we'll deliver this thing, right? And one thing that is true is that we do operate with much less developers than other big projects, in my opinion. And actually, it's not just in my opinion, it's definitely true. We can actually maybe show a presentation on this at some point. And this is generally like what we're fighting against. We have to do more with less people and much less budget. So it's not always as easy as it can maybe appear, and it maybe does not appear very easy. So let's see. Is there anything else? Oh, yes. For JavaScript versus Rust, almost all new code that we write is in Rust, except when we can't write it, or a Rust or Go. TenderDash is written in Go. So. Yes.
All right. If there's no more question, I would like to thank everybody, thank the team, and I'm glad that everybody is safe as well as able to work. And thanks everybody who were joining us for today's development update, and see you in 2 weeks. Wish you a great rest.